Ladies and gentlemen, my name is Yen-Luan Chen. I am the co-author, Chen are from Takming University of Taiwan. Today, it's our pleasure to show our paper with you. The topic of our paper is an optimal discrete schedule replacement policy for a multi-component system with value interaction. First, we introduce preface. We know that modern systems are often component systems consisting of multiple components. So we assume that a multiple component system consists of different components in our paper. And second, we assume that we know that the value interaction is common phenomenon in complex and large scale in industry plants, which may cause tremendous economic losses and unacceptable safety risk. So, in this study, we propose a generalized pre-article and random replacement policy, which are taken into considerations for a multiple component system with value interaction. Our system model consists that a multiple component system consists with n different components. Assume that components I equals from 1 to n has a value time xi with distribution f of t, survival f bar I of t, value rate Ri of t, cumulative risk lambda I of t. Suppose that components I experience one of the two types of values. One is the type 1 value, which is minor with probability qi, and type 1 value is corrected by a minima repel. The second is type 2 value, which is major with probability pi, and pi equals to 1 minus qi. Type 2 value induce in instantaneous value of remaining components. And then the system fails and is completely replaced by a corrective replacement, the CR for abbreviation. The following pages we introduce the variable in our model. If no preventive replacement is considered, then that Zi be waiting time until the first type 2 value for component I, and its survival function can be obtained as follows: h bar I of t, like these equations. Please refer to it. Define Zi as the time to first system CR. It is easy since that Z equals minimize Zi. Then the survival function is given by h bar I of t, like these equations. Please refer to it. If a multiple component system operates n successive random jobs, then it would be better to perform the PR action after all jobs are completed. Suppose that the J's working time Yj with distribution G of t, survival G bar of t, Gi of t, survival G bar J of t. Replacement model. This study investigates a discrete schedule replacement policy for a multiple component system with value interaction and the successive random works. We consider such a system is planned to implement preventive replacement PR for abbreviations at pre-article time KT or completion of n random working times, whichever occur first. The aim of this paper is to find the optimal discrete schedule replacement time K star and N star that minimize the mean cost rate. We define cost structure as follows. CP is PR cost, CF is CR cost, and CM is minimum repair cost. Then we can propose the mean cost rate function. It can be obtained as the following equations. Please refer to it. Now we propose the optimization approach. When n approach infinite, the multiple component system is replaced preventively only at a pre-article times kt for given t. In this case, the mean cost rate to replacement becomes as the following equation, like this. Please refer to it. So we derive the optimal K star that minimize the mean cost rate CW of K for given T. To minimize CW of K with respect to T, and the optimal number K star satisfies the equalities like this and this. A finite and a unical solution K star can be shown analytically and computed numerically. When K approach infinite, the optimal component system is replaced preventively only at number n of work. In this case, the mean cost rate to replacement well becomes as the following equations. Please refer to it. We derive optimal n star that minimize the mean cost rate CW of n for a given t. To minimize CW n with respect to n, the optimal number K star satisfies the equality like this and this equality. Then a finite and unical solution n star can be shown analytically and computed numerically. This page we present a numerical example to our finding. To prove our finding, consider components I failure time xi is variable distribution f of t, like this. And the working time of j work yj has a exponent distribution g of t, like this. The following data are useful parameters as these terms. For example, n is 3, alpha is 1, and so on. Then the optimal discrete replacement policy and its minimum mean cost rate is presented in the following table. Please refer to it. From this numerical result, we can derive the following remark. One, similar to our anticipic result, table shows that existent and finite and unique optimal solution for each PR policy. Second, all minimum mean cost rate discrete, along with the increase of the minima repair probability. And finally, the optimal pre-article replacement number K star extends as the minima repair probability increase. It is instituted because the lower probability of catastrophic value result in a lower mean cost rate and a less PR schedule. Okay, this is the end of our presentation, and thank you for your attention.